Let's prepare some aldehydes and ketones. We've done almost all of these already, so we can go through this pretty quickly. For aldehydes, we can oxidize a primary alcohol, right? This is primary because this C only has one R group attached to it. Pyridinium chlorochromate, that gentle oxidizing agent, will only oxidize it up to the aldehyde. More harsh oxidizing agents will oxidize it all the way up to the carboxylic acid. Gentle oxidation of a primary alcohol makes an aldehyde. If I do oxidative cleavage of an alkene, if the alkene has an H on it, that one will turn into an aldehyde. If all of our alkenes are fully substituted, we get ketones through ozonolysis. So we have to have at least one with an H on it if we want to get an aldehyde out from the reaction. Take a look at this name, 6-oxoheptanal. The two carbonyl groups have essentially equal priority, but the aldehyde wins because it is attached on the end. So 7-carbon chain. The primary functional group is the aldehyde, so that's what the name ends with. We have this carbonyl on carbon number 6, so that's why it's 6-oxoheptanal. In the last chapter with our sulfides and sulfoxides, I said that dimethyl sulfide is an excellent reducing agent. So actually the procedure that I see commonly used with ozonolysis is step 1, O3, step 2, dimethyl sulfide, CH3S, CH3. Right, that's DMS. Because that gets oxidized into dimethyl sulfoxide, S double bond O. Well, it reduces the malozanide intermediate in there to make the 2 carbonyls. So we're going to talk much more about this in the carboxylic acid chapter. Any kind of carboxylic acid derivative, so any kind of C double bond O with something special attached, like an O or an X or something like that, those can be partially reduced to an aldehyde. The harsh reducing agents like lithium aluminum hydride will reduce them all the way down to the alcohol. This compound right here, diisobutyl, right, here is 1, 2, 3, 4 the carbons with a branch in the end, so that's isobutyl, diisobutyl aluminum hydride. It's so bulky that the hydrogen is not nearly as available as it is with lithium aluminum hydride. So it only adds really the one equivalent of hydride. Right, so H minus attacks this oxygen. Then the second step, the electrons come back down, kick out the leaving group, so that we're just left with the H there. So our book calls it DIBAH, dibah, or something like that. I've always known it as dibol or dibol H, just a variation on the acronym. Dibol is actually pronounceable, so that's what I've always heard. To each their own, and organic acronyms, I guess. We've also seen several ways to prepare ketones. Same sort of deal with oxidation, except this time a secondary alcohol, one with 2 R groups, will be oxidized into a ketone. And we can use any oxidizing agent we want. Might as well use the gentler one because that'll be more compatible with other functional groups that are present. It won't mess with double bonds and things like that. So PCC again, excellent at oxidizing secondary alcohols. Like we said before, we can do ozonolysis of an alkene. Any that had 2 R groups attached to them will become ketones. We did Friedel-Crafts acylation in the EAS chapter. Remember, the aluminum chloride makes this acid chloride into a stabilized carbocation, CH3C. Just like that. Stabilized by resonance with the oxygen's electrons there, and stabilized so that it does not rearrange like a Friedel-Crafts alkylation would. So that's an excellent way to make a ketone that is attached to a benzene ring. Has to be a carbonyl next to the benzene ring, and the R beyond it can be whatever we like. Back in the alkynes chapter, we talked about mercury catalyzed hydration. What this does is a Markovnikov hydration, so it adds water across the triple bond to make an enol, So what's this? 6 carbons? 1, 2, 3, 4, 5, 6. Via the enol, which rapidly converts into the methyl ketone form. If I have a terminal alkyne acid with this mercury 2 plus, you can just write mercury 2 plus if you want, will make a methyl ketone. So excellent way of making a methyl ketone out of a very synthetically useful terminal alkyne.